All right. So welcome to Introduction to Psychology, the online course. This is the first week's lecture on the science of psychology. So when we think about psychology, psychology is a science in the same way that chemistry, physics, other disciplines are sciences. The difference between psychology and physics is content. Psychologists study behavior and thought. We study how people think, why they do what they do, as opposed to particles, gravity, um, the movement of atoms in space, those kinds of things. But what's important is that um, the goal of science is to answer questions about our world. And science is more about the process by which you go about answering those questions, as opposed to the particular questions that you're asking, as opposed to the subject matter that you're interested in studying. The basic scientific method, if you think back to your high school science classes, is this five-step process. First we have a statement of a question. Why is it that some people behave aggressively and some people don't? Or you could come up with any number of questions. Why is it that some people will help someone in an emergency situation and other people won't? Or you come up with a variety of questions. And then you design a research study. So perhaps maybe you think, well, one reason why people don't help people in emergency situations is because they think that someone else is going to help. They're not responsible. So you design a study where you set up some scenario where a person falls down and you try and address this research question that you have with this study. You measure variables. So when we're doing research, we're measuring, you might measure how long it takes a person to help. You might measure maybe the number of people that are standing around. Maybe it's the case, and as you'll see, it is the case, that when there are more people around, there's a greater diffusion of responsibility. People are less likely to help, so you might measure the number of people around. There's a variety of different variables that you could measure. Once you've measured this, you analyze your data. This is where statistics come in. And then you draw conclusions. Well, we found based on our study that people took significantly longer to help when there were more people around compared to when there was no one else around. And we think that one of the reasons why people help or don't help has to do with the influence of other people. The important thing about this five-step process is that it's iterative. There is no end point to research. One thing that we will learn, or that you learn in a research methods course, is that one particular study doesn't prove or disprove anything about the world. We accumulate evidence, and it's based on this accumulation of evidence that we draw overarching conclusions about the way the world works. And each individual study is just one piece of evidence that we consider. And so in this way, the conclusions that we draw from our research just go back into our research questions. We've learned something, and now we take that knowledge and we ask a different question, or we ask the same question in a slightly different way, and we do another research study. So psychologists, we use a scientific method to study human behavior. We start with this research question, like I mentioned. One important thing about a research question is it has to be what we call an empirical question. And empirical just means that it is a research question that can be tested, that can be observed, either directly or indirectly. So, for example, if I am interested in the effects of video game violence on aggressive behavior, and I believe that people who play violent video games are more likely to be aggressive. Or I ask the question, do people who play violent video games, or do people who consume violent media, are they more aggressive? That's an empirical question. I can set up a study. I can put people into a room and make them play Grand Theft Auto and then give them the opportunity to shock someone. And I can see the people who played Grand Theft Auto, are they more likely to shock someone compared to people who play Tetris or some other non-violent game. There's a way that I can set up a study to test my hypothesis, to test my idea. And we'll talk about hypothesis in a minute. That's what defines an empirical question. It's something that is observable. It's some study that we can conduct. You can contrast this with things that are unobservable. You can think of things like mediums. Someone claims that they can speak to the dead. That's an interesting claim, but there's no real way that we can empirically determine whether or not they actually can speak to the dead. It's not an empirical question. Another sort of easy non-empirical question is, does God exist or not? The existence or non-existence of God is not an empirical question. There's no study that we as scientists can set up to test that idea. And so things that are not empirical are really sort of outside of the realm of science. Science really isn't interested in things that are not empirical, or at least shouldn't be. So once we've got a question, then we come up with a hypothesis. So, the research question might be, do people who consume violent media behave more aggressively than those who don't? And then we can come up with a hypothesis. I predict that people who play Grand Theft Auto for an hour are going to be more likely to shock people than people who play Tetris for an hour. A hypothesis is an explanation. It's a prediction. It's sort of your predicted answer to that research question. Okay. Now we contrast a hypothesis with a theory. A hypothesis is a specific prediction. It's a specific answer to a specific research question. A theory, on the other hand, is sort of an overarching explanation that organizes our thought around a particular topic. So one sort of easy contrast is a hypothesis, a specific prediction. A theory is sort of a general overarching explanation. So for example, a hypothesis might be that if a child observes an adult play with a toy in an aggressive manner, so if a child views, this is taken from sort of a classic social psychological study, if a child observes an adult, beating on a doll with a hammer, then that child will also, behave in an aggressive manner with the toy. Right? Specific prediction. The research question might be, do children learn aggression by watching adults? We come up with this specific hypothesis. The theory, and the theory involved with this hypothesis is called social learning theory. And social learning theory suggests that one way people learn is just by observing other people's behaviors. Now notice this is a really broad explanation, right? It's trying to understand how do people learn. Well, one way that people learn is through observation. The hypothesis is specific, it's testable. We can set up a situation where a kid observes an adult behaving aggressively, and then we can measure or we can observe whether that child will behave aggressively following that aggressive modeling. Okay? So again, the difference here is specific and general. Notice that social learning theory can be applied to other hypotheses, right? So maybe we have another hypothesis that if the child observes an adult behaving in a gentle or caring manner with a toy, that then they'll model that behavior, right? Same theory, but a different prediction, right? We might make a prediction about a completely different domain. Maybe we predict that, well, if it's true that people can learn by observing other people's behaviors, then maybe someone could learn to operate a piece of machinery just by observing someone else operate that piece of machinery, right? So again, the idea here is that hypotheses are specific, theories are general explanations. Now, we as humans operating in the world, we come up with theories and hypotheses every day. Right? I have this hypothesis that it makes my wife really upset if I leave the toilet seat up. And I could do a test. I could leave the toilet seat up, and then I could observe her response. And if she's upset, then I know that I've sort of learned that my hypothesis is supported. Right? We do this every day about social interactions, about all sort of things in our life. The difference between what we kind of do in our daily life and the way that we think about the world is that scientists, we do this systematically, right? We set up a very rigorously controlled situation and test this idea. We test the boundaries of this idea, right? So, for example, social learning theory suggests that people can learn through observation. We could ask the question, well, is there a situation where that is not true, where this theory falls apart? Are there some kinds of behaviors that people just simply cannot learn through observation alone? So another example, we sort of have this intuition that we have this idea that our intuitions are accurate, with this theory that our intuitions are accurate. And this might lead us to this hypothesis that, don't change your first guess when you're taking a multiple choice exam. And the idea here is that, we might think that, well, people who don't change their answers are going to have more correct than those who do change, right? That's a specific hypothesis. And the theory is sort of, well, our intuitions are accurate. Now, we might, have an experience where we don't change our answers and we do better than we thought we did. And we would, personally see that as sort of confirming evidence of our hypothesis. A scientist would approach this more rigorously. We would instruct half of the people to go on intuition and half of the people to be freely changing their answers. And then we would see, do the people who change their answers do better or worse or the same compared to the people who don't? Another aspect of science is this idea of a variable. In science, we often want to quantify and measure variables. And a variable can be anything. It is the quality, some quality about people or their environments that changes. Anything that changes is a variable. You can think of the aggressive behavior example. Whether or not the child punches or hits the doll in the example. Punching and hitting is a variable. We can measure that. We can count up the number of times a person punches or hits. Okay. Typically, hypotheses describe relationships between variables, right? So, for example, another couple variables that we talked about the relationship between consuming violent media and aggressive behavior. Violent media consumption and aggressive behavior are variables. We can measure the amount of time someone plays a violent video game or the amount of violent movies that people watch. We can measure aggressive behavior in a variety of different ways. We can make predictions about the relationships between those variables. Once we have a prediction, then we start designing our study. There's a lot of different strategies for conducting research in psychology, and I'll just briefly mention these. Surveys are typically used to kind of describe the state of the world. Maybe we just want to know how much violent media people consume, so we can send around a survey, asking people about, how often do you watch violent movies, how often do you play violent video games, those kinds of things. Surveys really give us an indication of sort of what the state of the world is right now. You can think of things like polling data, Gallup polls and those sorts of things. Those are examples of surveys. They tell us, how much do people support the war in Afghanistan or President Obama, right? Those are surveys. Experiments are when we're actually manipulating variables. And experiments are really crucial to research, and we'll talk about that in a fair bit of depth here on the next couple slides. There are also naturalistic observations. This is when you're sort of out in the world observing how people behave in their actual environment. So in my upper level experimental psych class, we do a naturalistic observation, and the research question that we're working under is, do people take longer to pull out of a parking space when someone is waiting compared to when someone is not waiting, right? So imagine yourself in a parking lot. you pull up behind someone and you're waiting for their parking spot, the question is that person going to take longer simply because you're waiting? And in my experimental psych class, we go out into parking lots and we observe and record the amount of time it takes someone to pull out of a parking spot, depending on whether or not someone is waiting or not waiting. And this is naturalistic, right? We're out in the real world observing people's behavior. There are also case studies. These are less common in psychology. They're typically reserved for sort of rare or unusual phenomena, right? People back out of parking spots all the time. That's not very rare. That's something we can easily go and study out in the real world. You can think of, rare diseases or rare psychological disorders where there's only a handful of people in the country who have this disorder. And in those instances, we can learn a lot by focusing on one or two individuals in depth. Generally speaking, when we're conducting research, we're looking at a sample of individuals, and that sample can range from 25 individuals all the way up to 3,000. And so that's the distinction there. We're going to focus on experiments because experiments are the only way that we can get information about causality. Right? So for example, if I did that survey where I asked people, how much do you play violent video games and how much do you watch violent movies? And I also asked them questions about, how often do you get in fights and how often are you verbally aggressive? These kinds of questions. And let's say I analyze my data and I find, yes, there is a relationship. People who play violent video games are also more likely to report, behaving aggressively and aggressive behavior. Well, I can't really know if the playing of violent video games is actually causing the aggressive behavior, right? It could be the case that people who are aggressive just tend to gravitate towards violent media, right? So it's important to understand the logic behind experimentation, because experimentation is the only way that we as scientists and scientists in psychology can sort of get at this idea of causality. So I'm going to go through this example, and hopefully this makes some sense. We can talk about this on the discussion boards this week. So let's say I have this theory that caffeine improves mental functioning. People who consume caffeine, they just have higher mental function. I'm predicting a relationship between two variables, caffeine consumption and mental functioning. When researchers conduct studies, one thing that we often have to do is what we call operationally define our variables. Psychologists often work with abstract variables, right? Aggressive behavior, love, I'm trying to think of some more, forgiveness, these kinds of sort of abstract ideas, right? Relationships between people, these kinds of things, right? In order to do a study, we have to operationally define. And that is to say, we need to take our variables and give statements of concrete procedures. What specifically do we mean when we say caffeine consumption? What specifically do we mean when I say aggressive behavior, right? Is yelling at someone, does that count as aggressive behavior? How loud does it have to be yelling? Does punching someone count as aggressive behavior? These kinds of things. So an operational definition for caffeine consumption might be drinking 2 cups of coffee. Right, so we'll go with that for now. So we can operationally define caffeine consumption as drinking 2 cups of coffee. An operational definition of mental functioning might be a score on an intelligence test. Let's say I've got this short intelligence test. It measures abstract reasoning, and this is how we're going to operationally define mental functioning. Right? The important piece here about operational definition is that we're taking these sort of abstract ideas and we're turning them into specific, concrete procedures, right? Caffeine consumption could be a lot of things, but by operationally defining it, we're saying specifically for this study, caffeine consumption is drinking 2 cups of coffee. Now remember, we're making a prediction, right? When we're doing an experiment, we're making a causal prediction, right? We're predicting that one variable is going to affect another variable. Or in other words, one variable is going to cause changes in another variable. So when we think of caffeine consumption and mental functioning, just think for a minute, what variable do you think is causing the other variable? Many of you probably said, or thought, caffeine consumption is causing increased mental functioning. That, the prediction maybe that we could make is that people who drink 2 cups of coffee, they're going to score higher on the intelligence test compared to people who don't drink coffee. But it could very well be the other way around, right? It could be that smart people who score high on intelligence tests, tend to gravitate towards caffeine consumption. Right? So when we're testing causal relationships, the way that we are able to determine causality is by manipulating one variable and then measuring its effects on some other variable. The variable that we think is doing the causing is the one that we manipulate. Right? If we predict that caffeine intake causes increased mental functioning, then we're going to manipulate caffeine intake. Right? One way we could do this is, you imagine we're researchers in our psych lab, and we bring participants into our lab, and we give half of the people 2 cups of coffee, and then the other half get nothing. They get no coffee, and then we measure mental functioning for both groups. Right? The variable that we manipulate, caffeine consumption, is the variable that we think is doing the causing. The variable that we measure is the variable that we think is being caused by the I'm going to say by the independent variable. That's on the next slide, right? We have different names for these. So the independent variable is the variable that's manipulated. It's the thing that's doing the causing, right? So if we believe that caffeine consumption improves mental functioning, then caffeine consumption is our independent variable. If you think back to the other example about aggressive behavior, if we think that consuming violent media causes an increase in violent behavior, then we would manipulate violent media consumption. Maybe we have half of the people play Grand Theft Auto 5 for an hour and half of the people play Tetris. The dependent variable is the variable that's measured. It's the thing that is being caused, right? And it depends, one way to think about this is that it depends in part on the independent variable, right? The independent variable causes the outcome, the dependent variable, right? So in our study, we're predicting that how you do on this intelligence test is going to depend on whether or not you got caffeine. Now, one important thing to consider is that oftentimes there are other variables that can explain a relationship between variables, right? Maybe it's not, let's say we do our study and we find that people who consume the 2 cups of coffee, those people scored higher on the intelligence test compared to the people who did not drink the 2 cups of coffee. Well, maybe it's not the coffee or the caffeine per se, but maybe it's the hot water in the coffee that is leading to greater mental functioning, right? Maybe it's some other aspects of the coffee itself, right? Because we have caffeine, but we also have hot water. There are antioxidants and other things in coffee, right? The idea here is that there are differences between the two groups beyond the ingesting caffeine. And when this happens, we call these confounding variables. They serve as an alternative explanation, right? So it may be the case that caffeine is causing an increase in mental functioning, but it might also be the case that hot water is causing an increase in mental functioning. Because in our original study, right, we said, well, half of the people get 2 cups of coffee, the other half get nothing, right? One sort of important way that we are able to determine causality is by controlling for all the differences between our two groups, between the two levels of our independent variable, so that the only thing that is different between one group and the other group is that independent variable. ideally everything else should be exactly the same, right? So in our study, one way we can make these groups as equal as possible is to brew decaf coffee and then dissolve into 1 pot of decaf coffee no dose, 100 milligrams of caffeine, right? Then we will give the decaf coffee to one group and the caffeinated coffee to the other group, right? The no-dose group, we'd call that the experimental group, and the decaf only, we'd call that the control group. And the important difference between this version of the study and what we just talked about is now both groups are exactly the same. They both get the hot water, they both get the non-coffee components, they both get all aspects of the study. Both groups are exactly the same, except for that 100 milligrams of caffeine. So this is the idea. What we want to do in psychology is we want to control for these confounding variables, right? These are any variable that systematically varies with the independent variable and can serve as an alternative explanation. By systematically vary, I mean, in the original example, 2 cups of coffee versus nothing, right? The people in 2 cups of coffee group got the caffeine, but they also always got hot water. And the people in the no caffeine group always got nothing, right? And so that systematically is different between those 2 groups. Now, there are other kinds of confounds that we can think about. Students will often, ask the question, well, what about baseline intelligence? Maybe the people in the caffeine group are just smarter. What about the amount of sleep that they got the night before, right? We all know that if we don't get a lot of sleep, we don't do very well in the morning, right? Perhaps the amount of sleep is really what's driving our study. One way that we can control for these kinds of confounds is through what we call random assignment, right? Random assignment is a really, really powerful way that we can control for individual differences that might affect our dependent variable. What we do is we randomly assign people to each condition. So we have these 2 conditions, either they get decaf coffee or they get decaf coffee with no dose in it. And when a participant walks in the door, we flip a coin. And depending on that coin flip, they either go to one group or the other. And the idea behind random assignment is by doing this, we're effectively equalizing those extraneous variables across both groups. And what I mean is that baseline intelligence is going to influence how well they do on an intelligence test. But if we randomly assign, then some of the people in the experimental group will be really, really smart, but some of the people in the control group will be really, really smart, right? The distribution of that variable of intelligence will be the same in both groups. And so effectively, both groups are equal on that before we start, simply by doing this random assignment. So one way to sort of think about this is that if we randomly assign, so we've got all these participants, look at them here. When we randomly assign, right, so we flip a coin, and some people go in the experimental group, some people don't. The idea is that if we just group them together, and then we gave them an intelligence test, right, and we looked at their average score on the intelligence test, the average of group A should be exactly the same, or at least in research we would say not statistically different from the average of group B, right? Because what we've effectively done is we've distributed the levels of intelligence equally across both groups. Some people in group A are really smart, and some people not so much. Some people in group B are really smart, and some people not so much, right? So by randomly assigning, we've distributed this characteristic across both groups. And if we gave them that intelligence test, then the 2 groups on average would not be different from each other. What we do then is we add the manipulation into the middle, right? So if we do random assignment, we're confident that the 2 groups are equal on intelligence before we do our experiment. Then we introduce our experimental manipulation. Group B, the control group, gets decaf. Group A, the experimental group, gets the no dose. They both experience the study in the exact same way. They both drink the same exact kind of coffee from the same exact kind of cup. And the only difference between the two groups is the presence or absence of that 100 milligrams of caffeine. After the manipulation, both groups take the intelligence test. Right? And the question I say is, if our hypothesis is correct, what would we predict about how the groups would score now? Many of you, hopefully, are probably thinking that, well, if our hypothesis is correct, then the experimental group should score higher on the test than the control group, right? And this is why we are able to determine causality, right? Because if the two groups are equal on intelligence before the experiment, and the only difference between the two groups is the presence or absence of our independent variable, or the levels of our independent variable, then we can say with some degree of certainty, well, the presence of caffeine must have caused that increase in intelligence, right? One important piece about this random assignment is that we assume that the groups are equal on the dependent variable before the manipulation. And what this means is that we do not need to measure and control for their baseline intelligence. Because we've randomly assigned, we know that the groups are relatively equal on intelligence prior to the experiment. And this is essentially what I said. Random assignment is super powerful, right? Simply by randomly assigning, we're controlling for all of these things: baseline intelligence, level of sleep, caffeine sensitivity. All of those things are being controlled for because we're equally distributing both of those. Those characteristics across both of our groups. So hopefully that gave you a little sort of inkling into the science of psychology. Next week we'll start by talking about neuroscience.